single solenoid valve has one solenoid to assist in valve operation. The valve spool shifts when the solenoid receives an electrical signal and is energized. The valve will remain shifted as long as electrical current is applied to the solenoid. Once the electrical current is removed and the solenoid is de-energized, the valve returns to its normal position by spring force. Fluid circuits designed to use single solenoid valves must maintain electrical current in order to keep the valve in its shifted position. Double solenoid valves have two solenoids, typically mounted on opposite ends of the valve body. This type of two-position double solenoid valve does not have a spring return. When the first solenoid is energized, the valve spool shifts into the first position. Even if the first solenoid is de-energized, the spool remains shifted. This is because there is no spring to return the spool to its original position. Energizing the second solenoid will send the valve to the second position. Even if the second solenoid is de-energized, the valve will remain shifted until the first solenoid is re-energized. Since there is nothing holding the valve in the shifted position other than friction, these types of valves should be mounted horizontally to avoid self-shift due to excessive airflow or vibration. If both solenoids are energized at the same time, the solenoids will work against each other and may cause the spool to become stuck, electrical burnout of the solenoid, or an overload of inrush current to the circuit, any of which will cause severe damage to the system or valve. A three-position valve has a spring-centered neutral position for its internal spool. Because of the centering springs, it's necessary to hold current on one solenoid or the other to keep the spool in one of its side positions. When each solenoid is energized, the valve shifts to the appropriate position. Anytime both solenoids are de-energized, the valve spool will spring to center and stop the fluid flow. Therefore, a three-position valve requires a maintained electrical signal for its operation. As before, energizing both solenoids at once may cause damage to the valve or to the system. To prevent this from occurring, electrical circuits should be designed to make it impossible to have current on both solenoids at the same time. Solenoid valves are used in both hydraulic fluid and air systems to control direction on cylinders from deceleration or speed control and pump unloading or pressure control. The physical appearance of each component will vary greatly depending on brand, size, and type, so care should be taken to reference the appropriate manufacturer's guidance when choosing a solenoid valve. Raindrop, drip, drop top, top smoking, no cooking the hot.